$86.6 billion. 86.6 billion, 9 zeros, is lost every single year from shoplifting. 5-finger discount. And that's all businesses. That's small, that's large, and that's according to a New York Times article. And then according to a Forbes survey, 75% of small business owners report monthly losses from shoplifting of $500 and $2,500. These are small businesses, the mom and pops, the corner stores. This is the difference between an entrepreneur succeeding in business and fulfilling their dream and losing per month. I even read an article one time that Nordstrom actually has to build into their economic models how much they lose. Now we're talking about loss. And this right here is a perfect problem and use case for artificial intelligence. How do I know that? Well, here you go. This is a local article, well-written, CBS News Detroit, about how retail owners are turning to artificial intelligence. How are they doing that? With AI, with machine learning, with computer vision. And they're utilizing a company called Vision. They are a French company. If I want to understand how the technology actually works and if there's anything proprietary, I bias towards patents, was a patent lawyer, and nothing. Trademark search, nothing. The only thing I could find about this company is that they're French and they have a Crunchbase profile. So I can't really uncover specifically what Vision is doing in this space. If there's anything unique, don't think so. I think what they developed was a great holistic product, can work out of the box for small business owners to put up in their shop and get an immediate ROI. I mean, let's just do quick math here. $2,500 lost per month. This subscription costs you, I don't know, let's say $300 a month. You have a net difference of $2,200. Let's say they don't catch everybody, but they catch $1,000. You're coming out ahead. We start really calculating return on investment from something like this. And now you see artificial intelligence in action, helping these small business owners stay afloat. And the Vision co-founder, Benoit Koenig, or however you want to pronounce it, does a great job breaking down exactly what it's doing. And the reason I don't think there's anything proprietary is because this is how it works. This is how anomaly detection works. This is how fraud, anything around a sort of detection model utilizing computer vision is going to operate in this sense. So the first component is human detection with a red or green square you can see around each person. If we go back to their website, there you go. You see it. Next component, it's called pause estimation to estimate the position of all the body parts. The third component is called object recognition to detect a backpack or a purse instead of a shopping bag or shopping cart. All these components together will provide you with the probability of any gesture at any time. And this is great marketing. This is great design. You can see it in action. And my assumption out of the box, this is what you're going to get from this product. I don't have any sponsorship, by the way. It's just, they did a great job. So you can see here what the co-founder, Koenig, had spoken about. Artificial intelligence and machine learning is all about probabilities. More likely than not, something is occurring. So you can see this individual here putting something within a bag, and the probability of item in pocket right here, 97% through the object detection. And we can get into it. We can see how these things work. Here's a study. Suspicious behavior detection on shoplifting cases for crime prevention by using 3D convolutional neural networks. Now, CNN's convolutional neural networks is what's used for computer vision. Takes an image, breaks it down into numbers because machines read numbers. They can't look and they don't have actual vision, and then can make inference and determinations from said image based on whatever training model that there is. And I noticed a lot of them use a publicly available data set. And let's see if it's listed here. It is the UCF data sets. There it is. We use this UCF crime data set. And so a number of these data sets are publicly available, and you're able to train models, like in this case, through what's called supervised learning. So you can tell the model, this is bad, this is good, and that way you can determine probability with future information, such as the imagery that's inputted or outputted from a camera, what something is based on the trained data set. And then you can use convolutional neural network existing training, kind of going off on a bit of a tangent here, but this is how this works, of different image sets for the object recognition. And then what you'll get is outputs of percentages, like right here. So then you have a initial data set of which you train. So when you have a large data set, you break it apart so you can train the model into what you're needing. You take one subset of it and you put that as a training set, and then you segment off a test set. So then you can validate. And what you see here, suspicious behavior, 18 identified versus normal, 100% accuracy, normal for 32. This is called a confusion matrix, and it can come in like nice pretty boxes and colors when you're looking in a Jupyter notebook and you're using different libraries to visualize this. But then you can evaluate the performance of the model. Here you see pretty decent accuracy. We measure these things based on accuracy, based on things like recall, precision. If you want to balance between recall and precision, there's things called F1 score, but recall is reducing false negatives, precision is reducing false positives. The more behind the scenes kind of things, how these things are evaluated. But here they chose accuracy as their mode for determining the performance of their model. Other instances, a scalable generalized deep learning framework for anomaly detection, very similar. So again, they used the UCF data set. They used a violence detection. So not only would this model, if included in Vision, perform for detecting things like shoplifting, it would also say, hey, more likely than not, there's some sort of violent act happening. And even in this study, they go to what object detection. So they use a bunch of different CNN architectures. These are, again, publicly available. You can pull them, and then you can do what's called transfer learning. So here they used MobileNet, Inception, ResNet, Exception, and then utilizing those publicly available data sets like the violence one and then the UCF data set, you could train something specifically. Like here, this is what it's doing. So they have image pre-trained models from each data set, and they're doing transfer learning, adding in each of the identified things like shoplifting, things like violence. So then, more likely than not, through all of this mathing, this dimensionality, this linear algebra, they can output what is going on in the videos. That's how it's working. Now, there's one more interesting evolution that I've seen with things like LLMs. And when we're talking LLMs, we're talking about things like OpenAI's GPT models, Anthropic's Claude, one of my favorites that I work on because it's open source, Meta's Llama models. And that's this really cool study, the garbage in, garbage out, zero shot detection of crime using large language models. Zero shot is when you're utilizing something and it doesn't need to be trained on it. So this is improvement of out-of-the-box functionality, and LLMs are being tested in ways for things like anomaly detection, and in this case, some sort of violent or robbery. And this is why. So video, taking what's on it and doing some sort of visual to text translation, and then leveraging here GPT-4 in what's called chain of thought, like explain what's going on and through the methodology. This is also correlated to what's called System 1 and System 2 thinking, something that Meta is trying to impute into their models. Thinking Fast and Slow by Daniel Kahneman, fantastic book, talks about how the brain works. So System 1 is the quick reaction things. System 2 is the methodical chain of thought thinking that our brains do. And then over time, through repetitive motion, System 2 thinking is distilled into System 1, and you can make better rationales much quicker. And what here is we see a System 2 way of thinking to reach a conclusion of what's going on in this video. So if you look here, what is going on from text, visual to text translation, GPT-4 outputs, 2 people are helping the driver of the silver car with a mechanical issue. 2 people are attempting to steal parts from the silver car. The 2 people are tampering with the silver car to cause harm. The 2 people are involved in a car theft. Most likely category, normal. Okay, not the best, but through, again, UCF crime data set. You can find it out there. They improve through getting the chain of thought thinking into actually, no, this is a bad actor. So just a really cool use case, and also kind of a quick discussion of what's going on behind the scenes and then the potential future down the road of how these things can evolve, get more intelligent, get smarter, improve accuracy and these probabilities of what's happening, because you, of course, don't want to accuse someone of something that they're not doing. So that's why you want to make sure, like in this case, you would put the negative as someone that is shoplifting, if I'm thinking through this, and that way recall could actually be the right answer. Or if you're a business, you actually want to make sure that even if someone isn't shoplifting, you want to catch them just to make sure that you're not losing money. And see, there's art meets science when it comes to a lot of these discussions on developing the right solution for a business use case. But looks like Vision made a great product for small businesses. They don't have to go through all the consulting and the development of it. Great job.